Good afternoon, class. Chapter 3, Derivatives, Section 3.7, Derivatives of the Logarithmic Functions. Here's part 2, reminding you the derivative of ln x is 1 over x. The derivative of ln of g of x is 1 over g of x times g prime of x. To differentiate, example 7, y equals e to the power of 2x times ln x. I'm going to put a raised dot in between, meaning we are going to use the product rule, f times g, which is f prime g plus g prime f, as you can see it here. So f prime. So this, to differentiate this, y prime starts with f prime. Any exponential of the answer is itself, e to the power of 2x. And then by the chain rule times 2. So this is f prime times g ln x plus g prime ln x is 1 over x times f e to the power of 2x. In other words, we have f prime g plus g prime f. We take the common factor of e to the power of 2x out times 2 ln x here plus 1 over x here, because we take the e to the power of 2x out as a common factor. So the final answer, y prime is e to the power of 2x, parentheses 2 ln x plus 1 over x. Y equals log base 3 of square root of x. We want to differentiate this. So far, we've been dealing with natural log, and we know the base is e, and we know how to take care of it. However, when the base is no longer e, how do we take care of it? We go with the change of base formula and say y equals log x base b equals ln x over ln b. We know that. In other words, 1 over ln b times ln x. 1 over ln b is just a number, is a coefficient, is a multiplier. So if I want to differentiate this, 1 over ln b remains, and I'm going to differentiate ln x, I get 1 over x, and I rewrite it as 1 over x ln b. So we're going to do the same thing here. But before we do that, we notice this one, square root of x, I can change it to x to the power of 1/2. And I can use the power rule, put the 1/2 in front. Remember, the best course of action in order to differentiate logs is to decompose them first. And now if I want to differentiate this, y prime, that 1/2 remains. I have to work on this, and I simply flip over the argument of log. I get 1 over x. And since the base is not e, 1 over ln b, 1 over ln b, 1 over ln 3 in this case. This is by the change of base formula. So the numerator, as you can see, is just 1. The denominator is 2 times x times ln 3. So y prime is 1 over 2x ln 3, and we are done. Question number 9, f of x is log base 5 of x squared plus 1. So in essence, we are tagging along the chain rule. In other words, if I want to differentiate log base b of f of x, well, f of x, I'm going to flip it over, 1 over f of x. Then by the chain rule, I need the derivative of the argument, which becomes f prime of x. Because the base is no longer e, by the change of base formula, as it was mentioned here, 1 over ln b. And that's exactly what we are going to do here. We can put them together in this format, 1 over f of x times ln b times f prime. So we are going to decompose this. There is nothing to decompose. Therefore, we're going to move on with differentiation. 1 over x squared plus 1, we're going to flip over the argument of log. Then we need f prime. The derivative of the argument is 2x. Then we need 1 over ln v because the base is not e, 1 over ln 5. So as you can see, a fraction bar, the numerator is 1 times 2x times 1, which is 2x. And the denominator is x squared plus 1 times ln 5. So f prime of x becomes 2x over x squared plus 1 or times ln 5 as the final answer. When we differentiate y equals ln of sine x, the first thing is, can we decompose it further? The answer is no. So just follow the derivative of ln of g of x is 1 over g of x, so 1 over sine x, times g prime, the derivative of sine, everybody should know that it's cosine x. So what we are dealing with really in essence is cosine x over sine x, reminding you tangent is sine over cosine over 1 over cotangent. Cotangent is cosine over sine over 1 over tangent. Secant is 1 over cosine. Cosecant is 1 over sine. Therefore, we should recognize this as cotangent x, and we are done. Y equals ln of ln of 5x. To really have an understanding of what we need to do, let's actually box this and just call it g of x. So it becomes easy to differentiate. What is the derivative of ln of g of x? 1 over g of x. So 1 over g of x, 1 over ln of 5x. Then times g prime. So just differentiate ln of 5x. And ln of 5x, you know, it's 1 over 5x times 5 by the chain. Very simple. By the way, ln of 5x is ln of 5 plus x. If you do that, it doesn't make it any easier. So as you can see, number 5 from the top and the bottom cancel each other. So the numerator is just 1, and the denominator is ln of 5x times x. We put the x in front because if we put the x here, 1 might be under the assumption this is ln of 5x squared. We don't want that, so we put the x in front. Y equals 1 half ln of 1 plus x over 1 minus x. We want to differentiate. So the first thing we do, using the quotient rule of logarithmic properties, this piece, so 1 half remains, this will cut into 2 halves, 2 pieces, ln of 1 plus x minus ln of 1 minus x. So that's decomposing the log completely. Now that we want to differentiate, we say y prime, that 1 half remains, and we are going to deal with the brackets. And to differentiate each piece, we are going to go with the derivative of ln of g of x. So this will flip over 1 over 1 plus x times g prime times the derivative of 1 plus x. It happened to be 1, but we have to write it to make sure not to miss anything. Minus, flip this over, 1 over 1 minus x. And then g prime. The derivative of the parentheses is negative 1. So it does make a difference here, as you can see. So what we really have here inside the brackets, this one is 1 over 1 plus x. This one is negative 1, negative 1. That means plus 1 over 1 minus x. So please understand, negative times negative, that results in a positive here. And so to differentiate this, to finish this, by the way, this is, everybody, this was the only calculus step. This wasn't, this was algebraic step. Algebraic step. To combine them, we want to find the LCD and combine them, algebraic step. This is the only calculus step. So 1 half, and as you can see, the product of 1 plus x and 1 minus x is the LCD. Now, how do we add them up? 1 times 1 minus x plus 1 times 1 plus x. And we're going to combine the numerator by writing 1 minus x plus 1 plus x minus x and plus x cancel each other. The numerator is just 2. The product of 1/2 and 2, they cancel each other, they give us 1. So we have a fraction. The numerator is only 1. The denominator is the product of 1 plus x and 1 minus x, which makes it 1 minus x squared. So the final answer, y prime is 1 over 1 minus x squared. Bear in mind, there was only one step of calculus.